Hey all, these are the last two concepts for Unit 8, so a quick kind of Unit 4 concepts, 3 videos. So we're going to cover 2 ideas here, and they both have to do with trapezoids. Trapezoids are different types of quadrilaterals. They're not parallelograms, but they do have 4 sides, so they're still quadrilaterals. So we have here a regular, basic, old trapezoid. And the thing that makes it a trapezoid is that only one pair of opposite sides are parallel. So if I look here at this trapezoid, I have one pair of opposite sides being parallel. And again, I made the mistake of showing they're congruent. See how easy that mistake is to make. So these sides are parallel. The other two opposite sides are clearly not parallel. So this guy is a trapezoid. And a trapezoid, the sides that are parallel we call bases. So it's got 2 bases. And the sides that are not parallel are called legs. So each one of those is a leg. So the trapezoid that we're mostly going to focus on is a special kind of trapezoid. It still has one pair of opposite sides that are parallel, has 2 bases, has 2 legs, but we call that, pardon me, an isosceles trapezoid. So this is a little different than the previous trapezoid because the legs are congruent. And then the diagonals are congruent. So if I draw the 2 diagonals here of this isosceles trapezoid, those 2 diagonals would have the same length. And we also know that the base angles are congruent. So that means if I go to one base, so here's one of the bases, that angle is congruent to this angle. I go to the other base, that angle is congruent to that angle. So if we know one of the base angles, we know the same angle on that base is equal to it. So isosceles trapezoid kind of gets its name just like an isosceles triangle, is that 2 legs are congruent to each other, and then the angles opposite are congruent to each other. Except in this case we have 2 pairs of congruent angles. So I've got an example here for you where we can kind of use those properties just like we did with the parallelograms and the special parallelograms. We can find different values just by being given 1 or 2. So here I have the length of this side, this one leg is 24, and I should tell you that this is an isosceles trapezoid. So if this leg is 24, those 2 are congruent, that means y is 24. Here I have one base angle being 76. This x angle is on the same base, so that means they are congruent, so that makes x 76 degrees. And we should know all of these 4 angles add up to 540 degrees because this is a, 360 degrees because this is a quadrilateral, 540 is a pentagon. If I add all 4 of these, they should add up to 360. And if these 2 are the same, that makes these 2 supplementary. So 76 and z need to add up to 180. So z is 180 minus 76, which is 104 degrees. So that would make this angle 104 degrees as well, and these 2 would be supplementary as well. So just knowing the properties of trapezoids, isosceles trapezoids, that's one of the ideas here. the other idea is this midsegment theorem. So this is 8.4. And a midsegment, what it is a segment that joins the midpoints of the two legs of a trapezoid. So the two middles of the legs are connected, and what we end up with is a special relationship between the length of that midsegment and the length of the two bases. So in this picture, I can see that segment EF is a midsegment. I can tell it's a midsegment because over here, the two smaller segments AE and EB are congruent. That means E is a midpoint. Over here, CF and FD are congruent. That means that F is the midpoint of this leg. So two midpoints being connected, that makes EF a midsegment. The relationship that exists is that the midsegment length, so the length of EF, is equal to the length of the two bases added together divided by 2. So the average of the two base lengths. So I just add BC plus AD, and I divide by 2, and that is the relationship. So if I know the two base lengths, then I can just plug them into this formula. I can add them together and divide by 2, and that'll tell me what the midsegment length is. Also, if I know the midsegment length and I know one base length, I can use this relationship to find the second base length. So let's do a couple examples here. I have midsegments. In this case, my midsegment is X, so I'm looking for that length, and it's equal to the two bases added together divided by 2. So my midsegment is 14 units long. Over here, I know my midsegment. It's 7. That midsegment should be the two bases added together divided by 2. So I need to do a little bit of algebra here. This should look like kind of one of the circle formulas we had. I need to multiply both sides by 2 to get 14 equal to 10 plus 2x. I'll subtract 10 from both sides and divide both sides by 2 to get x to equal 2. So if you know the relationship, just plug the values in where they belong, and we can use that to solve for a length. So I want you to try each of these. I should tell you that in this first one, this is an isosceles trapezoid, so those two legs are congruent. And over here, the segment labeled X is a midsegment. So in each of them, I want you to find the value of X.